Hello and welcome to this video. In this video, we will look into the the precise algorithm in which we can solve recurrence relations. Okay, let's get into the main crux of the video here. Okay, now a recurrence relation is a relation in which an, the current term, is dependent on the values of an minus 1, an minus 2, and so on, right? So the values of an minus 1, an minus 2 somehow influence the value of an. Now, in this particular example, in this particular algorithm, the flowchart that you can see, we are going to find out the general term for an when the recurrence of an is dependent on an minus 1 and an minus 2. So that is one step towards the back and two steps behind the back, respectively. Okay, so the given recurrence relation will be in the form of an is equal to something multiply an minus 1 plus something multiply n minus 2. And that particular relation can be written in the form as you can see, and I have circled it there in the first row. Right? That's the input for us. Now, in this, you see that the current term is an, the previous term is an minus 1, the term before that is an minus 2. Right, so an minus 2 is the most primitive of all terms. So, while writing the characteristic equation for this particular given recurrence, we assign the parameter 1 or k to the power 0 for that basically, right? Okay, the parameter given for an minus 1 is k, and the one above that is k squared. So you can see in place of an, we have written k squared. In place of an minus 1, we have written k, n minus 2, we have written 1. So we get a characteristic equation, which is a quadratic equation. Okay, now in this quadratic equation, we might get some real and distinct roots, maybe k1 and k2. It might be real and equal roots where k is repeated two times. It can be an imaginary root, and the imaginary root can be written as r e power I theta and r e power minus I theta. Right? So these are the three possibilities of the roots of this quadratic equation. Hey, by the way, you can check the roots by looking at the square root of b square minus 4ac, right? Or maybe not even the square root. You can find out the discriminant of this particular equation, which is cn minus 1 whole square minus 4 times cn multiplied by cn minus 2, right? So looking at this value, you can find out which is the case that we are going to consider. If the roots are real and distinct, we take the first case. If it is real, if there is only one root which is repeated, we take the second case. And if the roots are complex, they will be conjugate, of course, because the values of cn minus 1 and cn minus 2 are constant numbers. In that case, we shall get the values to be like imaginary, and this is the relation. Now, since we have got, like an dependent on an minus 1 and an minus 2, we shall be given in the question what is the value of a0 and what is the value of a1, right? This will be given to us. Or maybe A1 and A2 will be given to us, right? Now, using these two values, we will find out what is the value of A and B, right? This A and B, remember that these are unknown, but these are constants as well. So, from the initial conditions, we shall find out what are these values of capital A and capital B, and once we find out them, we substitute that in the corresponding relation. The first relation, if the roots are real and distinct. The second relation in the characteristic equation gives us real roots which are equal to each other. And the third one, if the roots are imaginary, I mean, have an imaginary part, right? So they're complex conjugate roots. So once we do this, we shall find out what is the general term of the recurrence relation. Okay, thanks for watching. We'll come back in a later video with some example on this. Bye.